Welcome to the live interactive session for the course Surface Water Hydrology being taken by Professor Dr. Rajiv Maiti. I am the teaching assistant Aman Srivastav, and today in this problem solving session 6 we are going to solve some of the problems on the topic analysis of hydrograph part 1. Today in this session we will be covering problems on these three aspects of unit hydrograph, namely catchment area, peak discharge and effective rainfall. So let us quickly start with the first problem of today's lecture, that is the estimation of area of a catchment. Let me read the problem for you. A 24-hour unit hydrograph of a catchment, triangular in shape, as you can see in this image, has a base width of 120 hours. So here the base width, that is comprising of peak time and recession time, is 120 hours and a peak flow of 60 meter cube per second. So here peak flow QP. So this value is also provided in the problem, which is 60 meter cube per second. Estimate the catchment area using this unit hydrograph. So we need to find out the catchment area. So let's see how to solve this problem. The step 1 will be to find out the catchment area using the properties of the triangular unit hydrograph. So what is that property? It is that the volume represented by the area of unit hydrograph is equal to area of catchment into 1 centimeter. What is this 1 centimeter? It is the effective rainfall or unit depth of rainfall. So this is how the volume is being represented of the unit hydrograph in terms of area and the unit depth of rainfall or the effective rainfall. So all these things are provided in the problem, that is the volume of the unit hydrograph can be estimated by finding the area of the triangle, that is half base height. So half into base, which is 120 hours, into height, which is 60 meter cube per second. These values were provided in the problem, and what is not given in the problem that we need to find out is the area of catchment multiplied with 1 centimeter, that is effective rainfall depth, which was already given in the problem. So now the only unknown here is the area, while other things are known. So let's solve this. So this 120 hours has been converted into seconds by multiplying it with 60 into 60, and this 60 meter cube per second is as it is taken. The centimeter has been converted into meter, that is 1 by 100 meter. Now all these values are in the units of meter and seconds. So solving them, the area of catchment will come as 1296 into 10 power 6 meter square, and we can convert this meter square into kilometer square by dividing this with 10 power 6. So this 10 power 6 will be cancelled out to become 1296 kilometer square as the area of catchment. This is how we will be able to solve these kind of problems, by remembering the basic property of the triangular unit hydrograph. Moving ahead, let's take this problem a little forward. In the second problem, we will be estimating the peak discharge given the other aspects. So a problem is a 10-hour unit hydrograph, triangular in shape, has a basin area of 2160 km square and a base period of 10 days. So compute the peak of DRH, direct runoff hydrograph, produced in the basin due to an effective rainfall of 10 centimeter in 10 hours. So these are the things given in the problem, and what is not given is the peak discharge, that is QP. The QP is what is unknown that we need to find out. Okay, so let's utilize the properties of the triangular unit hydrograph that we discussed in the problem 1. This is what we have studied in the previous problem. Now substituting half into base, that is 10 days, which is given, into height is what is the peak discharge, which is not given in the problem, and that we need to find out. And the area of catchment this time is given to us, that is 2160 km square, and the depth of the rainfall, that is 10 centimeters, also provided in the problem already. So substituting the values in the required units, that is meter and seconds, and solving them, we get the discharge Q as 500 meter cube per second, that is the final response. I hope you were able to catch this question, similar to the trend that we followed in the question number 1. Likewise, let's find out effective rainfall given all other aspects of a triangular direct runoff hydrograph. So in this problem, let me read. A triangular direct runoff hydrograph due to a storm has a time base of 84 hours here. So time base is 84 hours given to us, and the peak flow is 60 meter cube per second, this time given to us, occurring at 20 hours from the start. Okay, so TP, the peak time, is given to us, that is 20 hours from the start. If the catchment area is 453 km square, estimate the rainfall excess in the storm or effective rainfall. So this is what we need to find out, effective rainfall or rainfall excess. So we will be utilizing the same triangular unit hydrograph theory and the properties. This is what is represented here. Substituting the values, half into base 84 hour into height 60 meter cube per second, multiplying it with the area of catchment, that is 453 kilometer square, with effective rainfall, that is what we need to find out, which is unknown in this case. So substituting the values in a way such that we can convert them in the units of meter and seconds, and then solving them for effective rainfall, we get 0.02 meter or 2 centimeter, which is the final response. I hope this session helped you in understanding the properties of the triangular unit hydrograph, and also provided the information as to how to estimate the catchment area, peak discharge and effective rainfall using the properties of the triangular unit hydrograph. So stay tuned for more such videos with regards to the NPTEL course Surface Water Hydrology. Thank you for your time.